Okay, good morning. Welcome to
KidMath number 43.
KidMath number 43. So we're still playing around. What chapter is that? Is it chapter 13? 12 of Art of Problem Solving's algebra book. And today we spent a little bit of time this morning talking about conjugates, which is actually a new operation for complex numbers that we've never talked about before. And it seems pretty easy at first. So we have a complex number, a plus bi, and that's usually denoted by the letter z instead of x. So we usually use z for complex numbers. And we have a new operation called the conjugate, which we just denote with a bar. And I say this z bar.
Z bar.
Z bar, yeah. And it's just a minus bi. So it seems pretty simple, right?
Yeah.
Of all the operations we've probably learned, remember it took a long time to learn about addition when you were a kid?
Yeah.
And then multiplication and division. But here's a new one, bar, or called complex conjugate. And it seems like it doesn't really do too much, except it helps us do two things really easily. One, it helps us find a real number that relates to this number a plus bi. And then the way we do that is we take a plus bi, the number, times its conjugate, a minus bi. And when we multiply this out, we get a squared plus really minus abi plus abi. Are you following that?
Yeah.
Minus abi plus abi, and then minus, because I get a plus times a minus, b squared times I squared. But what's I squared?
Minus 1, so it's just plus b squared.
Plus b squared, because that I squared is a minus 1. So I get a squared plus b squared is the parts that don't have i's. And I get minus abi plus abi, which is?
Minus abi plus abi is just 0.
0. So when I multiply the number times its conjugate, I just get this a squared plus b squared.
Which is going to be an integer.
Well, no, not necessarily.
If this is true.
Well, if a and b are integers, this would be
Yes.
an integer. But these can be anything. These can be any real number. So this could be like square root of 2 and minus 7.8 or something like that. And there's a neat geometric interpretation of this. And pick any complex number you want with integers just to make it easy.
Let's do 3 plus 5i.
3 plus 5i. Apparently that number is invisible. 3 plus 5i. Okay? And if we go into the complex plane and we go over 3 and up 5, so just up a little more than we went across, we get here 3 and then 5. And then if this is a Pythagorean triangle here, we would get the c squared. C squared equals 3 squared plus 5 squared.
9 plus 25.
Which is?
It's 34.
34. Okay, let's see what we get when we multiply the number by its conjugate. Okay, we get 9 minus 15i plus 15i minus, that's plus times that minus 5i squared. But 5i squared is minus 25, right?
Yes.
So I get 9 plus 25, which is?
Which is 34.
34. Okay, so the number times its conjugate gives us the hypotenuse squared of the triangle that makes, so it tells us the square of the distance away from the origin. So that's a pretty useful property. It helps us turn any complex number into an important real number. Okay. Good job. That's the conjugate, and that's part of the reason why it's so important. And how do you say conjugate if you have a z?
Z bar.
Z bar. Very good.